Time is one of my favorite ones. Give me enough time, and I'll do what? I'll find a substitute. Give me enough time, and I'll find a substitute. You can jack up price now, and maybe get me now, but eventually I'm going to find a substitute for whatever it is you jacked up price on. Go back to gasoline. In the short run, the price elasticity of demand is 0.2. We're pretty unresponsive to price changes. But in the long run, how do we substitute? What do we do? Buy a new car. Exactly. We get a smaller car. We get a more fuel efficient car. It'll get us for a while. We're dumb, but we're not stupid. We're gonna adapt. Right? That Hummer looked really, really cool when gasoline was $2 a gallon. It's not too long ago. Gasoline was $2 a gallon 5, maybe 6 years ago. Remember all the Hummers you saw out there? No? How many Hummers do you see nowadays? Yeah, you don't see a lot. Where you did see a Hummer was on the side of the road in flames. And the owner calling saying, my Hummer got stolen and somebody parked it on the side of the road and lit it on fire. Can I have my insurance money so I can go buy a Prius? But we know that over time you're going to wise up and we're going to go from relatively inelastic to up to 1.5. We saw that with US cars. Right? It took me, I waited till my, you look at a 1972 Buick something or another, and we could probably fit this whole classic. And you're not going to sell it immediately. You'll wait till it runs its course, and you'll buy a Honda or a Toyota or something. In time, we'll find substitutes. People are smart, and not necessarily that we'll find substitutes, but someone will come up with a substitute, right? I'll invent something that's going to infringe into this market. It's an example of recent invention. Price segments. Yeah, this price products in lower price segments tend to be more inelastic than those in higher price segments. This kind of relates back to the question he was saying. What we see is, well, what we do know is this. For any demand curve, price elasticity isn't a constant, it's a variable. It changes. What does that mean?
You said it's not a constant, it's a variable?
Correct. So here's a demand curve. The idea is price elasticity is going to vary from 0 to infinity. And at that halfway point of a demand curve, price elasticity equals 1. Halfway between 0 and infinity apparently is 1. So that along this portion of the demand curve, elasticity is less than 1. This is considered the inelastic portion. And over this portion of the demand curve, elasticity is greater than 1, and this is considered the elastic portion. What it means is the price elasticity of your product depends on where you're at on the demand, on your demand curve. And you can move from one range to another. So we know that along this range, price elasticity is less than 1, but it's going to get higher and higher and higher until eventually it becomes 1. And consumers aren't going to continually take price increases sitting down. Eventually they're going to get up and leave and buy something else. And they're going to exert their purchasing power. So toothpicks are inelastic because they're relatively cheap. If price elasticity was constant along the entire demand curve, then toothpicks should be a lot more than whatever they are now. When you look at price elasticities, you're really looking at small changes in price. The idea is to look at small changes in price. You're looking at kind of neighborhoods of price, going from here to here, right? Not gigantic increases in price. You're not going to go, toothpicks aren't going to go from $2 a box to $20 a box. You're going to change prices at the margin. And in that case, then toothpicks will be relatively inelastic. But we could push demand over into the elastic portion if we keep jacking up price. Here are some more of those Coke and Pepsi demands. So we talked about the price elasticity of demand. There's also an estimate of the income elasticity and the cross price elasticity. So we talked about the price elasticity. Coke consumers are less sensitive to changes in the price of Coke. A little bit more brand loyal. Income elasticity. So Coke consumers are more loyal. Income elasticity is greater than 1 for Pepsi. It's less than 1 for Coke. What did we call a good with an income elasticity greater than 1?
Inelastic.
Inferior?
No, that was negative. Positive, anything positive is normal. It was a luxury good. Exactly. What does that mean? Coke consumers are a little bit more loyal, but apparently Pepsi consumers, if you hit the lotto, you're going to switch from Coke to Pepsi. It's more sensitive to price changes. Pepsi is more for higher income people. That's what it says. It'd be interesting to see the demographics of Coke and Pepsi consumers and see if it's consistent with these
They
things.
calculate that based on consumers' income range and the product they want.
Yeah.
How are you getting the cross price elasticity?
Excuse me?
Is that just the
Cross price elasticity is how responsive is Coke to a change in the price of Pepsi, which is this one. How responsive is the demand for Coke to a change in the price of Pepsi? Relatively, well, for every 1% increase in the price of Pepsi, let's just move it the other way. For every 1% decrease in the price of Pepsi, Coke is going to lose 0.61% in demand. Pepsi consumers are a little bit more price conscious. They're more willing to switch, right? At least in terms of the magnitude. For every 1% increase in the price of Pepsi, in the price of Coke.
Is the cross price elasticity the substitutability or
It
not?
has to do with the substitutability, the direct substitutability.
So Pepsi people are higher income people, but they're more sensitive to the price. When it changes, they switch.
They're less loyal and more sensitive to price changes of the competitor, exactly. They're more willing to switch.
Which one?
Pepsi. But they're higher income, they're classier people. They're just not loyal.
Higher income, that just means class.
That's not me, it's.
Just means higher income.
Yeah.
So like Coke will lose 0.61% in demand as Pepsi does. What?
Lower sugar.
As if Pepsi lowers its price by 1%.
So what does that mean on the other way? So what if Pepsi raised their price? Coke only goes up 1.61?
If Pepsi raises its price, correct. Coke only goes up 0.61. But that makes sense too, because remember, Coke consumers are more price insensitive relative to Pepsi consumers. So these results, the nice thing about this is we see these aren't symmetric. They're not switching, their willingness to switch isn't the same for both brands. It's different. Different demands, different products, same category. And some people could be switching to RC Cola or 7-Up or one of the other drinks. But when you buy Nielsen data, you usually get it for a category. I mean, if you go, the data we're getting, for example, is for categories. So you're gonna get the competitive set. If you buy data for soft drinks, you're gonna get Coke, Pepsi, 7-Up, and all those soft drinks. When you buy data for wine, you get all the wine sold at that store. When you buy it for orange juice, you get all the orange juices. So you buy it for product categories, so you get the competitive set. And you can calculate these cross-price elasticities. Oh, all right. Both are price elastic due to substitutability. Both are normal, but Pepsi appears to be wealthier, and they are substitutes as indicated by the sign. But demand for Pepsi is much more responsive to a change in the price of Coke than vice versa. Pepsi drinkers are more likely to switch. But we knew that from the price elasticity of demand. So the cross-price elasticity measures substitutability of a direct competitor, but really the brand loyalty, the measurement of brand loyalty is the price elasticity, not the cross-price elasticity.
With the cross-price elasticity, you spoke of, it's in regards to any soft drink, right? Or is it just Coke in general? Coke, the version of Coke and Pepsi.
For this, it's Coke relative to Pepsi and Pepsi relative to Coke. But in the problem set you're going to do, we're going to have a competitive set, and you're going to have to choose which is the more appropriate competitor. Yeah.
From like a company standpoint, would you want Coke with more elastic?
Yeah, I think so. It's got better brand loyalty. It's got less cross-price elasticity. The only bad thing, I guess you can say, is that if we think incomes are rising, people are more likely to switch from Coke to Pepsi than vice versa. So,
Did you ever notice that Costco in San Jose Menlo Park used to serve Coke maybe a year ago or so? They switched to Pepsi.
and they switch back. Yeah.
They switched back.
Yeah. There was outrage when they stopped selling Coke. Right? Coke's at Costco? No. I don't drink Coke, so, unless it's with alcohol. All right. Advertising, brand loyalty, and price elasticity. More demand stuff. You never thought you'd love demand curve as much as this. You never thought it'd be so much fun. Amazing, isn't it? All right. Looks like we have an increase in demand here. What is that? Advertising increases demand. Which increases sales if we hold the price constant, or increases price if we hold quantity constant, or some combination of the two. So advertising is going to shift that demand curve, and we should have either more pricing power or be able to sell more, or again, some combination of those two things. But notice the way we draw this, and this is the way it's drawn in most textbooks, whether it's microeconomics textbooks or marketing textbooks, which usually don't cover this anyways. But if it was a good marketing textbook and the authors knew what they were doing, this is how they would represent the effect of advertising. But those are a lot of ifs, none of which would apply to anyone here.
I have a question.
Yeah.
When we're graphing, like for our homework this year tonight, when we're graphing, like log demand graphs,
Yeah.
you said something about having the price and the quantity switched. Are we gonna be marked off if we did switch them?
No, the only time it's fine to not switch them is when you're drawing demand curves. If you're running regressions, you have to switch them. Otherwise, you're running the wrong regression. Does that make sense?
Yeah.
Because when you run a regression, you gotta have price on the x-axis and quantity on the y-axis. Well, what else does advertising do? Think about advertising. The goal of advertising is to increase demand, increase sales, hopefully increase pricing power. Is that a good thing or a bad thing? Let's see. What if the demand curve doesn't shift out like it does in many textbooks? What if it does something like that? Is this good or bad?
Well, at that same quantity, your prices moved up, which could mean more revenue.
Yeah. And the demand curve really becomes more inelastic. So what advertising can do, not necessarily what it does do, but what it can do is create greater brand loyalty, right? I have to have Air Jordans. I'm not gonna wear Reebok, I'm not gonna wear Adidas, I've gotta have Air Jordans. And if I can't afford Air Jordans, I'm gonna kill you and take yours.
Which has happened.
Which has happened quite a few times. And this is it. This is the example of advertising creating greater brand loyalty, right? More price inelasticity. This is ideal. This is good. Greater pricing power, greater brand loyalty. Go back there. But the opposite's true also. What if the demand does this? So I've attracted more consumers, I've got a greater demand curve, mostly. But who am I attracting? Oh, I guess it's
Low price.
marginal consumers. Maybe people that were buying a competitor, they like the ad, they're buying my product now. But these are consumers that are more price sensitive.
So would this be like when you do, kind of like offers on the products, like buy one, get one, buy two, get one free and things like that? 'Cause you would
Exactly.
attract
You're
people
getting
that
those,
pay less.
you're getting those marginal consumers that are buying simply because it's on promotion of some sort. There's some sort of advertising effect going on here. And advertising we'll use as a broad category to include promotions and those kinds of things. And really, you know, in this case, you've attracted more consumers, but these aren't brand loyal consumers. These aren't your core consumers. You're attracting what's called marginal consumers. They're on the margin of buying or not buying. This ad, for whatever it did, for whatever is going on here, it attracted more consumers. And normally you'd think that's good, but it may not be. Clearly you can sell more. But your price elasticity, we see this curve is flatter. Consumers are much more price elastic. They'll bail as soon as you try to raise price. Which is it? What is advertising doing? Is it, are you attracting marginal consumers? Are you creating more brand loyalty? Is it some of both? These are questions that brands want to know. They want to know, who am I attracting? Who are these new consumers that I'm getting? Are people just buying more of my product? Is it my existing consumers becoming more brand loyal? Am I attracting some of these marginal consumers that are going to leave pretty soon after my advertising ends or whatever? And we want to be able to measure that. Probably using regression. Definitely using Stata. Any questions? The deep breath after I mentioned Stata. Again with this Stata. All right, let's look at a data set. That is, I can't tell the number. Yeah, definitely someone that's been working out. Okay, screen resolution there. This is strange. It only does this on this computer. I do this in other classes and it doesn't do it. Yes, it's wine data, unfortunately. Cases, price should be in there, yes, price. We got income in there, so we can estimate a income elasticity. And is this the same data set from the last problem set?
No, we only have the C, B, B, and the B, F, A.
Okay. So we've got definitely a much bigger competitive set here. And we can try to measure, which one is our closest substitute. To whatever one we're looking at. So we'll have to pick a brand and see what we get. So do we have income in the last one?
Yeah.
So You had income, so, but you didn't use it, right? Did I just do this? No. All right, no, that's the. So what did we do? Are we looking at Blackstone? What'd you guys look on the last problem set? Close ball? This is Blackstone. Again, we're blessing. We've got, I don't know, how many brands we have in there, price and quantities for all those brands. And we picked Blackstone this time, and it looks like the law of demand. We clearly got some outliers here. That. But outside of those two, the law of demand seems to hold. And we're not going to do simple regression. We're going to add in income and competitor prices. So we're not going to be able to represent these things in 2 dimensions. But we see that at least price and quantity for this brand seems to obey the law of demand, despite what the wine experts say. Interesting, those two outlines. This one is. Have we used? It's like the same graph. Oh, it's the same graph, but I just switched the axes. Let's do this. We use the M-label function. M-label is nice for just looking at outliers. Why? Because these labels are going to be on top of each other when you in the cluster. But those are fun. We really don't care about those. What we want to see are those outliers. And as we would have expected, what are they? They're N and D of our OND, right?
Say that in
They're November and December.
They're November and December, which are the big sales months for wine. The wine industry people say OND all the time.
I thought we were going to start putting price on the X.
It doesn't matter.
Okay.
We can do it either way. As long as we don't run the regression this way, we're fine.
Okay.
So once we run the regression, we'll switch it. So we can do it the other way. We'll just switch it.
It's also probably Costco. No, there's a
All right, so there we go.
discount on Blackstone.
Why those, I mean, look at the other Novembers and Decembers, they tend to fall within the cluster. Why is that one especially just out there? Let's investigate a little bit more. It's fun, isn't it? 2009. So 2009's November and December were different than pretty much every other year's November and December. What was going on in 2009?
Traded down?
Heart of the recession, right?
Yeah.
And this is Blackstone. Blackstone is, how much is Blackstone? Cheap? Inexpensive or cheap?
Well, 8 to 10, so 7 to 10 was your.
What happened? Just disappeared. So yeah, those are probably the results of the Great Recession, which was the greatest recession since the Great Depression. So even the outliers are completely explainable. Outside of the Great Recession, which was huge, look at the demand. It's a tight distribution, linear. You can see just fitting the demand curve in there relatively easy. And of the Great Recession, it looks like only those 2 months, November and December, which are the big selling months, were the ones that were affected disproportionately, right? At this price, demand shot up at around $9 and then around $8. It was even more popular. Trading down, exactly. Let's see. Let's regress, predict cases. And we have price on the right axis. Look at that line. I mean, that line is, even with those outliers, and outliers can be a problem. But even with those outliers, that is you would think I just pulled this out of a textbook. It's a really, really strong linear fit. Just visually, we can see that it's a pretty good fit. What do the statistics say? Yeah, -80, statistically significant. We got an R squared of 54, which means 54% of the variation in sales of Blackstone is explained by one thing, price. That doesn't include the other things. What is this? Oh, yeah, those are those months. So let's add in some of those other things. Here's our old friend I month. R squared, adjusted R squared went up to 61%. Most of our coefficients are negative except for February and March. Well, and then November and December. Significance, however, is relatively low for, these are the strongest ones, 1.8, T-stat of 1.8, and a T-stat of 1.67.
What about 2.76? Right.
Oh, 2.76, yeah. So in June, yeah, sales are really falling significantly, statistically significant.
Can you go back up to your table before you did the I month?
The regression table?
Yes, please. Okay, so that's just by itself, and then when you do the I month, then it takes 2 through.
Yeah. And if you want to, we talked about moving the, changing the base category. Did we change the base, have we changed the base category? All right, so let's learn something new. This sounds stupid, and it is stupid, but it is what it is. a lot of the time, companies don't like seeing negative coefficients. They think it's bad. So, if I want to make them happy, what do? Change the base. These are all relative to January, which we know, especially with Nielsen data. If this is 4-week data, then January is going to include a lot of that December data, those December sales. So if I change, which month could I change it to make everything look positive? June. That one big negative coefficient that's significant. Does it matter? Absolutely not. But for whatever reason, B6. For whatever reason, that makes people feel more comfortable than the previous one.
So your month one though now is defined as June, right? So
No,
it's-
month one is still month one.
But we switched that
Yeah, look
54
at that,
to
number 6
June.
isn't there anymore.
Month one is still month one. Now the omitted month is,
Row 6.
so everything's gonna be, before everything was relative to January. Now everything is relative to June.
So it just pulls that 1 month out.
Yep,
So your base month is still January,
my base month is June,
June.
is 6.
So, with our first one, we had negative coefficients because the cases that we sold in January was higher than all the rest of them.
True, yeah,
So in June-
mostly, yeah.
Yeah,
So we're
in June,
comparing
yeah.
everything relative to our, one of our best months. Now we're comparing everything relative to one of our worst months.
Okay.
And the coefficients are positive. The model's exactly the same. The predictions, any forecast, everything we do is gonna be exactly the same. The only thing is the optics. People like positive coefficients because it looks like they're doing well. Negative coefficients, it looks like we're not doing well. Oh my God, we're dying in June. You're still dying in June. We just got rid of June and compared everything to June, so you can't see.
You're just skewing the data and
You're not skewing it, you're skewing the presentation.
Okay.
So
of
in
the
month
data.
12, is the above graph, is it still 87.77 but negative?
No, because it'll
Change,
be,
Because the constants change,
yeah.
right?
So, but what this says is in December, I'm gonna sell 87 more cases than I do in June.
Okay.
Before it was in December, I'm gonna sell, I think it was still positive, but it was small. So in December, I'm going to sell, I can't even, 33 more cases relative to January,
Okay.
to January. Yeah.
But you're saying the graph will look the same if I've graphed that?
Everything will look the same. Everything is the same. It's the exact same model.
So we don't even need to take that step unless we're presenting it to someone who would care about the coefficients being positive.
Yeah, and sometimes, you know, yeah, it's insane, but sometimes you'll get like a heads up. If you're dealing with people that actually know what you're doing, in the wine industry, that's not gonna be the case. But if you're dealing with people that know what they're doing in another industry, then may give you a heads up, you know, make sure your seasonal dummies are positive instead of negative. It's just, remember, you've got mostly, you'll have a room of people that are mostly MBAs, most of whom have never taken a business intelligence course because this course didn't exist a few years ago. And most MBA programs don't do regression and all this stuff. So they're still using Excel. They're still doing spreadsheets. They're still doing, so regression to them is relatively Greek. And trying to explain to them, why are all those freaking coefficients negative? That's bad, isn't it? But if I do this, then this is all good, even though the results are exactly the same. it's, you know, it's like, this is, you know, probably not a good example, especially on tape. But, you know, they say when, you know, if you wanna look thin, hang out with fat people. If you wanna look tall, hang out with short people. So, you know, this is the same thing. You're still the same height. But if your friend's 5'2", you know, I look like John Wayne or, you know, whatever. You know, versus if I hang out with someone that's 6'8", I don't look like I'm 6'2", is what I am. You're right, it's ridiculous, it's stupid, but it just is what it is, so. And it really is from people that don't understand what's going on, so. But if you wanted to avoid believe me, I've been in these presentations where the presentation stops while I sit there for 45 minutes, an hour, trying to explain to them what's going on. It's not necessarily a bad thing, it's all relative. You know, when I should have just done this and we would have just glossed over it and nothing would have been said, so.
Were we looking at different data when the chief stat was that 276? Because now all your,
Nope.
it's the same one.
Nope. Because we were comparing everything to a good month. And what we're saying is, like for example, look at December. December is not statistically significant, at least by our rule of thumb 2. That just means we're not, December, one of our best months, isn't statistically different from one of our other best months, which is January. But now, December is clearly better than our worst month, and it's statistically significantly better than our worst month. So, yeah, and but it's the same. The model's still the same. The results are still the same. It just changes the base. Now I'm hanging out with a short person or a fat person, and it makes me look taller and thinner. You guys know Sarah Dove? I was talking to Sarah Dove and another woman that is like her height. So I'm between these two girls that are both almost 6 feet. And I forgot someone came up to, it looked like I was their child. I should be holding their hand or something. So I immediately said, I got the hell out of there. I'm glad it's not on the picture or something because it wouldn't have looked good. But,
You just mentioned something there. The T value, that changed now where more of the numbers are above 2. And we used to use 2 as our qualifier.
because more of these are statistically significant than our worst month.
Yes.
Our base was one of our best months, and we weren't necessarily statistically.
I understand we switched the base, but now, by switching the base, maybe, had you partly asked, is it a significant change? And you said no, but now we'll be saying yes.
Correct.
What does that mean? What does that translate?
It means that we're significantly different than our worst month.
Okay.
But but some of the coefficients weren't necessarily significantly different from our best month.
Would you ever exclude data then on a T value like that because it was under 2 the first time, but now you run it again with a different base and now it's above 2, so you would include it? Does that mean anything?
It means everything, because really, I mean, think about the interpretation. For example, in March, what is before May? April. Think of April. April, it's positive, but it's not statistically significant. All this means is that April sales are not much different than June sales.
Yes.
And that's important to know. Just as it's important to know that December sales are statistically different from June sales.
Yeah. What I'm wondering is regarding proportion of T value. So the absolute value of 2 isn't always the golden rule of what you want to see.
Yes, it is.
Because it is.
Yes.
Well, because in the other case, when the base was
Because the base was
January,
different.
Yeah, but But now they're significant, where previously they weren't.
Because the base was
Because
different.
the base was different.
Yeah.
Okay. So, just stupid.
All right. Okay. Let's add in, what are we missing, income? Do we like this regression, or you wanna go back to the regular one? Stick with the positive? Makes us happier?
Oh, real.
Yeah, let's go raw. Let's throw income in here. And based on what you know about wine, what do you think the coefficient's gonna be? Based on what you know about Blackstone, what would you expect it to be?
Negative.
And it is. Yeah. Yeah, and it makes sense. So it's negative and it's statistically significant. I don't think this is news to Blackstone. Calling Blackstone an inferior good doesn't mean it's a bad good. Remember, it's just relative to income. It just means inferiority and normality is entirely defined relative to income. As income goes up, fewer people are gonna drink Blackstone, they're gonna move up a price segment and drink something a little bit more expensive. Better. But the opposite's true. When incomes go down, people are gonna move down, trade down, and start buying more Blackstone. So during the recession, and we saw that, we saw those outliers during the peak of the recession, 2009. We saw just those two observations were really, really unlike all the other observations. That's the effect of that income effect. That's the effect of the inferiority of that good. That's how many people traded down to start buying Blackstone at the heart of the recession.
So the negative income coefficient means
It's an inferior good.
it's an inferior good, and if their income increases, they're gonna buy less Blackstone.
Correct. Correct. If we take logs, then we'll get price elasticity, an income elasticity, and then we'll have the months in terms of percentage changes. Double log, logs on both sides. So we want to log cases, we want to log price, and we want to log income. And we'll get elasticities. And those are the measures. Remember, it's hard to interpret 55 cases or 0.11 cases. But we can understand percentage changes. We understand elasticities.
So in order to do that, would you just use that same equation, but just put ln in front of all of them?
We gotta generate it out. Yeah, we gotta generate it out. So, I don't think they're natural logicized yet, although that's not really a word. It's,
So if price is ever negative, if price is ever positive, red flag, right?
yes, if price is positive, you screwed up.
Yeah.
Well, or you have an incomplete model. So, and I mentioned this before, I did work for a company that, I consulted for a company that they were looking for a better estimate of their goods. And I was telling them, they were explaining their model, and I noticed the negative price coefficient. And I said, well, that's positive. And I said, that shouldn't be positive. And he said, well, we get positive price coefficients all the time. You know, and this was a Stanford PhD in stats. He said, how do you explain that? With his smoking jacket and a cigarette with a stick on it. I don't think they actually did that. And my response was simple, you did it wrong. The law of demand should hold, even for your product. If the coefficient on price is positive, what does that mean?
Supply.
It could be supply, but let's say it is demand. But if you had a positive, think about
The more you charge, the more you sell.
Yeah.
the more you charge, the more you sell. Then I should just keep jacking up price from $8 to $500. Why? Because my price coefficient says I should. you're either wrong or you're severely underpricing your good. My guess is you're wrong. You screwed up somewhere. So, again, this is all real data. This is Nielsen data. We're pulling out SKUs, and things are coming out, but there are issues that come up. So let's do that. So generate ln cases equals natural log of cases. Generate log price equals the natural log of price. Generate the natural log of income equals the natural log of income. So far, so good. So we just can't put an L in there. We're going to define the variables first. We've generated natural log. Now everything is an elasticity. So we've got a price elasticity of demand of 2.4, basically 2.5, which means for every 1% increase in price, consumers are going to buy 2.5% less. It's over 1 so in absolute value. It's over 1 in absolute value. So we define that as price elastic. Consumers are relatively price elastic.
Wait, what you said one more time?
So for every 1% increase in price, consumers will buy 2.5% fewer cases, whatever our units are. Remember, we don't really know what 52 cases or 80 cases, is that good or bad? Is that a lot? I don't know. We would have to look at how much they sell, but now we've got a percentage change or an elasticity, and we can get a better idea of how responsive our consumers are when we look at an elasticity relative to a change in cases.
This is just a little more general. So the reason we do the logarithm is just to kind of make a better comparison in general, just from a general standpoint.
Because we like the interpretations, yeah. We can interpret these as elasticities, which are really nice. Sometimes it normalizes the data. It makes the data more linear, so the model fits better. Notice the R squared. Our dummies are still dummies, but instead of looking at the number, remember these are 58 or 43 or something. Now these are percentage changes, right? So in December, I sell 13.7% more, and it's statistically significant. In November, I sell 8% more. In October, I sell 10% less, and so on and so on and so on. So now we're looking at percentage changes throughout the year. We're still accounting for the seasonality, but now we can look at the percentage changes in sales as opposed to the absolute value. Not the absolute value, but the number of cases.
So once we exceed 10%, once we exceed 10%, becomes like statistically significant. Is that what we're getting from this?
10% where?
Just once it exceeds 10%, it seems like.
Oh, for the coefficients? Yeah, in this case, yeah, in this case.
Where's that?
He's just looking at the size of the coefficients, and he's saying when it's around 10% or so, then we're getting statistically different from 0. So you see this is about 8%, 13% significant, 7% not, 18% yes, 21% yes. Just looking at the size relative to the significance. All right. about? You gotta start bringing enough for everybody. Smelling barbecue, now I want to drink. Let's do this. Let's we can't throw in this. We need to find a substitute. So table cases. Let's do this first. Summarize. What are we doing? Blackstone. Blackstone is BS. I don't mean that. So Blackstone, let's do one more. All right, so Blackstone, it looks like is ranging from what average price of $8. The lowest price $7.69. The most expensive price $9.89. So that sounds about right. It should be. It's scan data. Of our competitive set here, BFE is Behringer Founders Estate. We already met Clos du Bois. BG is, what is BG? What's that?
Behringer.
Behringer, yeah. C8. There's no C8.
Seller number 8.
Seller number 8. Chateau Saint Michel. CC is Fetzer, J-Lore, Robert Mondavi Private Reserve.
If you browse the data details, it'll tell you the names of all of them.
No. Because I defined these. So let's do this. I'm just going to pull one out. Not cases. Well, this has a pretty similar average price. Yeah, this is 840, we were at 880, low price. Low prices are pretty similar, 769, well, 675, Behringer Foundry Estate's a little bit cheaper. 970 on the high end, 989, pretty similar overlapping goods. So let's use Behringer Founders Estate. Let's log it. Generate. All right. What sign should our substitute good be? Positive or negative? Let's go back to the PowerPoint. That thing always screws up the screen. So if it's positive, but should it be positive? A 50-50 chance.
It should be positive relative to the other things that the substitute good. Like, when the price of those other things goes up, demand for the substitute good will go up because they'll switch to
What other things are you talking about?
well, if Behringer Fountain Estate is substitute good, and
Its price goes up.
its price will go up.
No, if its price goes up.
If its price goes up,
Then what should happen, if they are substitute, what should happen to Blackstone?
Down.
It should go down?
They go up.
no, when Blackstone
Oh, it
goes
should go
up,
up.
Oh, the
DFE could go up as well, as long as it's still less price than Blackstone.
No. How do we interpret any coefficient? So it's basically. And these are logs, so these are
This is
elasticities.
the percentage change.
Oh, let's pretend it wasn't. Quantity demanded Blackstone, change in the price of Behringer Founders Estate. And let's say this is our beta. How do we interpret any coefficient? For every unit change in the price of Behringer Founders Estate, what's gonna happen to the quantity demanded of Blackstone? If it's positive,
Generally, a 1% change in price.
no, unit. If it's positive, then as the price of Behringer Founders Estate goes up, I'm gonna buy more Blackstone?
Less.
More, yes.
Yes.
As the price of the,
If the price of Behringer Founders Estate goes up, will I buy more Blackstone?
yes,
Why?
because it's your substitute.
Because I'm substituting into it, yeah. I'm buying less Behringer Founders Estate because that's a law of demand, and I'm buying more Blackstone. Now, if it's an elasticity,
So
we
looking at
just,
it-
we just convert that to a percentage change. So now, for every 1% increase in the price of Behringer Founders Estate, all the demand for Blackstone goes up by 0.71%. For every 1% increase in the price of Behringer Founders Estate, the quantity demanded of Blackstone will go up by 0.71%. And, I've got an angle here, it's statistically significant, yes. And it's statistically significant. So it's consistent with what we believe at least the sign of a substitute good should be positive.
So just explain to me what it would tell you if it was negative.
Then they would not be substitutes, they would be what's called complements. It would mean that when I go to the store, I don't substitute from one good to the other, I buy them joined together. So think of hot dogs and mustard or buns, hot dogs and buns, or chips and salsa, or things that you buy together. And what that means is, and think about it, if the price of chips go up, I'm gonna buy less chips. I like salsa with my chips, so what else am I gonna do? I'm gonna buy less salsa. So those are complementary goods. And if you got a negative coefficient on what you thought was a substitute, again, there's probably something wrong. Because it could be that Blackstone and Behringer Founders Estate are complements. But you have to think in terms of a consumer. What does that mean a consumer does? I'm gonna grab a bottle of Behringer Founders Estate and a bottle of Blackstone, because I like to drink. them both together. Exactly, it really doesn't make sense, yet, kind of like the people that, for this multinational, multi-billion-dollar corporation that are getting positive price coefficients, that didn't seem to bother them. Even though it's ridiculous to get, it's even more ridiculous for a price coefficient. But for these, yeah, sometimes you've got to fix the model. But this makes sense. And again, we kind of just picked this because it was in alphabetical order, I think. Or at least in order in terms of the data. But it made sense. It looked like the right price segment, and we threw it in there, and we get a consistent sign. The nice thing, one of the things that about retail analytics is that each store, Safeway has a different wine selection than Raley's. So maybe Raley's doesn't even carry Behringer Founders Estate. Probably does, but maybe it doesn't. But it's going to have a different competitive set. So my main competitor at Safeway is going to be different than my main competitor at Raley's, which may be different than my main competitor at Costco. So a lot of this analytics has to be done on a chain by chain basis. And even geography probably matters too, because not all wines are shipped to all states. So maybe, well, it's a different chain, but there's Safeways outside of California, right? Yeah. So Safeways out of state may have a different competitive set than, yeah, I know that because I already told you some of this data is from Safeway Seattle. And I've got Safeway Portland and some other things. So, and you've got different competitive sets. So you wouldn't want to run this and then tell your Safeway people in Seattle, well, this is what I find, and they'd say, well, we don't even have Behringer Founders Estate, so check your data first. The data is not general. It's going to be specific to whatever consumers are choosing among at that particular store in that particular state. So for this data, and I think this is Safeway Seattle, it's a substitute. Looks like they're substitute. And we've got 104 observations, so we got a decent sample size. It's not a really big sample size, but we've got a decent sample size. Any questions? Did we get out of 940 or 1040? Let's get those two numbers. Is that it? Right, I guess we're done.